Hello everyone. Welcome back to the course on Learn to Read Architectural and Structural Drawings with ETABS. In this particular lecture, we'll try to see how the structural drawings are given, and especially we'll try to understand how the footing layout looks and how we have to understand that. So before that, we'll try to understand how to what are the drawings that is usually released once the architectural plan is decided. We'll try to understand that, and then we'll try to see how the footing layout is going to look. So we'll quickly get into that, right? So architectural drawings we already seen with the help of a AutoCAD drawing, right? In the AutoCAD drawing, if you can remember in the previous lecture, these are the AutoCAD drawings what we had seen. So all these are the architectural drawings. So in the architectural drawing, we are going to get only the column location, but we are not going to get anything related to the size of the column, the footing dimensions, and the depth of the footing, the excavation depth, and all. For that, we need to refer the structural drawings, and that we'll try to see. Yeah. So coming to the structural drawings, what we have, the first one is the footing layout and the column layout. Always whenever a drawing is released, so these are the drawings usually what we need to refer initially. The footing layout and the column layout, both the drawings will be released simultaneously. And based on this drawing, we are going to do the execution. So we'll try to understand them. Once the footing and the column layout is released, along with that, they are going to release the typical footing cross section. So in the typical footing cross section, we are going to get the depth of the footing, right? I mean, what is the depth of the excavation we need to do? How many numbers of bars have to be placed? Whether we need to make use of 12 diameter bar or whether we need to make use of 16 diameter bar. What is the spacing between the bar that has to be kept? How the meshes have to be arranged? All those things we are going to get from the typical footing cross section. After that, what the drawing that we are going to get is plinth beam layout. We are going to get a plinth beam layout and the plinth beam reinforcement details. That is, what is the diameter of the bar that you have to use in the plinth beam, whether you have to make use of 16 diameter bar, how many bars at the top of the beam, how many bars in the bottom of the beam, what is the size of the stirrup that you have to use, what is the center to center spacing between the stirrup. All these things we are going to get in plinth beam reinforcement. After that, whatever drawings we are going to get, that is like the ground floor, first floor, second, third, and fourth, you're going to get the beam details and the slab details. Since beam and slab are casted monolithically, we're going to get beam and the slab details together. So all these are the drawings that we are going to get, and all these things we'll try to see in our course. So as of now, we'll try to concentrate on the footing layout. So we'll get into that. So this is how a footing layout looks. So you can see it here. What is written here? It is written here footing details, right? So since it is a footing layout, we are going to get, this is a footing details. We have to refer this drawing, which is called as footing layout. It is written here footing layout. This is a drawing that we need to refer right now, right? So before understanding the structural drawings, we need to go through the notes what is written in the structural drawings. We'll try to see them. So concentrate here. What is written here? The first thing is that about the notes, all the dimensions are in inches. So the structural engineer is going to, so who will give all these things? A structural engineer is going to give all these details. Whereas the architectural plan, whatever we saw in the AutoCAD, this is usually done by architect. But if you work in the small company, a architect, a structural consultant, everyone will be a single person. But when we work in the very big companies, and when you have a huge projects to be done, in that case we'll have an architect, we'll have a structural consultant, right? But if you're working for a small project, structural consultant is going to give this planning. Along with that, he's going to give you the structural drawings. Whereas in the big companies, these structural drawings will be given by the architect, and this uh, yeah this architectural drawing will be given by a architecture, and this structural drawing will be given by a structural consultant. So now let us say these are the drawings given by the structural consultant, and we'll try to understand them, what is trying to tell us. The first point what has mentioned is all the dimensions are in inches. So whatever dimensions we are going to refer in this particular drawing, everything is in inches. The second, what he has written, read this drawing along with relevant architectural and service drawings. So what is trying to tell, usually what happens, there may be some dimensions which may not be clear in the structural drawings. In that case, what you have to do, you have to refer the architectural drawing. These are my architectural drawings. We have to refer the architectural drawings for those things. And also sometimes what happens, we'll have a cutout in the house, right? We'll have the cutout. Now let us say you have a lift here. For the lift, what we need to do, we need to give the cutout in the slab, right? All for all these things, we need to refer the architectural drawing, because these things will not be mentioned in the structural drawings. So also for the staircase, what is the width of the staircase? Even these things we have to refer in the architectural drawing, so that while doing the casting of a slab, we are going to give the cutout in that particular portion. Now let us say you have a if you refer here, you have a cutout here, right? You have a cutout here. So you have a cutout here. This will be not this these things will not be mentioned in the structural drawings. This has to be understood through a architectural drawing itself. Based on the architectural drawing, when we do the casting of a slab, we are going to give a cutout in the slab of this dimension. Whatever dimension is mentioned here, that dimension of cutout will be given. So that is what he's trying to tell us, that read this drawing along with the relevant architecture and the service drawings. The third point is that do not scale the drawing, follow written dimensions only. So whatever dimensions is mentioned in this drawing, we have to blindly follow that. We don't have to do the conversion and all from the feet to inches, or you don't have to exactly scale it. Whatever is mentioned in the drawing, the same has to be executed at the site. The fourth point, what is trying to tell, yeah. Next is trying to tell us any discrepancy in the drawings with respect to the architecture and the service drawings should be brought to the notice of the consultant within 7 days of the receipt of this drawing. So usually what happens, usually there won't be any problem with the drawings once we release it, especially for the small buildings. Just in case if you feel that there is some discrepancy in the drawing, if you feel that, like if you're a very good contractor, and if you feel that the footing what the structure consultant has given, he may not he may not have done the proper sizing of it, or if you feel that the steel that he has given is less, or if you feel that the steel what he has given is more, in that case what you can do, you can consult the structure consultant, and you can bring it to his notice that these are the certain problems what I'm facing. Or if or you can tell like, I feel this is not the I feel the steel that is given in the drawing is very less. So you can speak to the consultant. So that is what he's trying to tell us. Usually that doesn't happen, because since we consider a lot of factor of safety and all, that things usually don't come. But in big projects, this certain changes keeps on happening because of the client requirement. These things keep on changing. So that is why he's trying to tell us, if there is any discrepancy in the drawing, we have to bring it to his notice. Next, what is the fifth point? The fifth point is concrete mix of M25. So this particular building what we are seeing, G+3, in this particular building, I need to make use of the concrete of M25 grade, where M stands for mix, and 25 is the characteristic compressive strength of the concrete. So I'm taking this course thinking that you guys have basic knowledge of civil engineering, and you know what is grade of concrete, what are the different diameters of the bar available, lap length, development length, and all. If you guys are not able to understand, then there's a course of mine on Udemy, building construction step by step with AutoCAD drawings, which is more than 21-22 hours. You can enroll into that course, where I explained you all the basics of the civil engineering, and also the construction sequence, how the construction is going to happen, how the excavation is to be done. All the things is explained over there. So I don't want to waste my time in explaining each and everything here. Anyhow, if it is required, I'll explain it here, but there might be something which you may not be able to follow. In that case, you can enroll into that course, you can watch there, and once you develop a basics there, you can try to understand all these things. Anyhow, I will be explaining you all the things here. There might be something which I don't want to explain it again and again. If you find it difficult, you can enroll the course there, or you can watch it through some other uh, way, and you can understand that, right? Yeah. So the next, what is written here, grade of steel, the grade of steel is Fe 500. So in this particular project, I need to make use of the steel of Fe stands for iron, and 500 is a tensile strength of that particular rebar, that is called as 500 Newton per mm square, right? Next, what is written here, clear. So these things Fe 500, all those things will be written on the rebar itself. If you observe the rebar very carefully, your different diameters of the bar, like 8 mm bar, 10 mm bar, 20 12 mm bar, and then 16, 20, 25, 32, 36, these are the common diameters of the bar that is available in India. In US or in some other countries, this diameter may vary. In some country 14 bar is also available, 22 bar is also available, 28 bar is also available. So based on the bar, we can do all these designs. So as of now, he's trying to tell you that you have to make use of FE 500 is a grade of a rebar that we need to use. And he has given here clear cover to the main reinforcement shall be. So in the column, usually it is 40 but whereas he has mentioned it 30 sometimes you can even make 25 but here it is mentioned we have to give a clear cover of 30 in the footing it is mentioned we have to give 50 has a clear cover. That is a minimum, usually what minimum what we use in the footing. And in the beams what we use is 25 and in the slabs what we use is 20 So these are the clear cover that we need to give during the execution of the work. So the clear covers are given, I mean the covers are given in order to avoid the or stop the corrosion of the rebar. That is the first point. The second point is that in order to have a good bond between the concrete and the rebar, we are going to give the cover. And the third reason is from fire resistance point of view. Let us say your building has caught up with the fire. In that case, I don't want my rebar to get exposed to the fire, because if my rebar get exposed to the fire, my rebar has carbon content in that, and carbon is a good conductor of a heat. So the moment fire catches to the rebar, the carbon comes in contact with that, and suddenly the steel is going to lose its ductility and also the strength. As a result of that, the entire building is going to come down. In order to stop that happening, we are going to maintain a space between the rebar and the outer face of the concrete. So that space between the outer face of the concrete and the rebar is called as cover, and that is given with the help of a cover block at the side. But what we represent here is clear cover. So these things also, it's a very basic thing, and we have to understand all these things. These things will be written in notes. Along with that, it's written here, this structure is designed for G+3 only. So the structure consultant has made it very clear that this particular building what he's designing is only for G+3. That is, you have a ground floor, first floor, second floor, and third floor. So this is a, and over that you have a smaller terrace portion that is also included in that, but usually we call this as G+3. So over that we cannot make any other floor. So that is why he has mentioned here, this structure is designed only for is designed for only G+3 building, G+3. So why do we tell all these things in the general notes? Because let us say this is a plan given today, and due to the shortage of money, due to the shortage of money, I cannot do the execution of this plan, right? Now let us say after 10 years, after 10 years I felt like I have to do this construction. Now I'm telling you the worst case. Let us after 10 years I want to do the construction. I have enough money with me after 10 years, and I want to do. So in that case, my idea also changes, right? Instead of G+3, I feel like I want to add one more floor over that, and let us say I want to construct for G+4. So in that case, whatever the drawing this structure consultant has given, this we cannot use, because this drawing is specifically meant for G+3 building. Just because you developed the idea of constructing one more floor over that, that doesn't mean that we can use this particular drawing. Again, we have to approach to the structure consultant, and for G+4 we have to get the design done, because this design what you can see here, and yeah, I'll try to show you. So whatever the footing sizes we have got, all this all the size of the footing, the depth of the footing is designed considering the load coming from the structure, that is up to G+3, that is ground floor, first, second, and third. So if you want to construct one more floor, in that case, this drawing will not work out. We have to do the analysis again, and then we have to release the drawings. So that is why usually what happens is we mention all these things in the drawing itself, so that there is no a problem with the structure consultant later. And the last point is SBC of the soil is assumed has 230 kilonewton square meter as per the client instruction. So SBC stand for safe bearing capacity of the soil. See, we know that once we construct a building, the entire load of the building will be taken by the slab. From the slab it will be transferred to the beams, and from the beams to the column. From the column, ultimately it is going to come to the footing, and from the footing the load will be transferred to the, from the footing the load will be transferred to the soil. So ultimately soil is a person who has to take that load. So I want to check whether the soil has that capacity or not, right? So that is why we do this soil testing. So that is why this is the answer what we have got. SBC is the safe bearing capacity of the soil. It is assumed to be 230 kilonewton per square meter, and this is usually done with the help of a geotech consultant. So a geotech consultant is the one who studies about the soil, who is going to give you the report about the soil, that what is the capacity of the soil, how much load this soil can take up to this particular depth. Let us say it can take 230 kilonewton per square meter up to a depth of 5 feet. So these are the things what is mentioned in the I mean given by the geotech consultant. Based on that we are going to do the design, and based on that we are going to give the depth of the excavation and all, right? So usually these things will be mentioned here, so that there is no discrepancy later once we do the execution, right? Yeah. So these are the general notes we need to understand initially, and once we understand these general notes, we'll try to understand how the footing layout is going to look. So we'll try to see them. So whenever we get a drawing, the first thing is you have to observe it here. It is written here plan, and it is a footing layout, because footing is the first thing that we are going to do, right? Once we have done the leveling and all, we have to do the excavation of the soil, so that the footing is going to go down. We are going to rest the footing, right? So that is why I need to get the size of the footing. What is the size of my footing? What is the depth of my footing? All those things we are going to get from the footing layout. So it's mentioned here, footing layout. And this footing layout what we are referring right now is the footing layout for this particular plan. You can see the plan, right? So this is a plan what we have. So it is my ground floor plan. So I have a two circular columns here, a two circular columns here, a single circular column here, and a single circular column here. Other than that, what I have the red color what you can see here. These are the columns, columns, columns. So on this column, I mean, yeah, so below this column, we are going to get the footing, right? So let us say this is my column. Let us say this is my column. So this is my footing. So this footing will be taken. This footing will take the load of that column. So that is why wherever there is a column, we'll get a footing here. So how many columns are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. These 12 are the rectangular columns what we have, and these are the circular columns what we have. So it comes out to me, we have 12 rectangular columns, and 2 is 4, 5, and 6, and we have 6 circular columns, right? So altogether 12 plus 6, 8 comes out to be 18 number of columns we have. So because of that reason, either we have to get 18 footing itself. Just in case if it is a combined footing, we are going to get 2 or 3 footing less. Let us say these two columns, if I make this as combined footing, then only one footing is going to come here, only one footing is going to come here. So all those things depends on the structural consultant, how we have designed it, right? So we'll try to see that now. Yeah. So now you can observe it here. Yeah, I'll try to zoom in. Yeah. So first we'll try to understand what do you what this A, B, C, D, E, F represents. So the A, B, C, D, E, F, all this represents the grid lines. So this grid lines will give us an idea. Will give us an idea how much should be the center to center distance, how the marking has to be done. All these things we are going to, is going to give us idea. The second is, these are A, B, C, D, E, F. All these are the grid lines. They are the vertical grid lines. These are the vertical grid lines. Similarly, on the horizontal side, we have another grid line, that is 1, this is 2, this is 3, and this is 4, this is 5, and this is 6. These are the grid lines. Now coming to the footing, if you can observe it, if you observe it carefully, what is written here? It's written F4 here. So F4 is the name of the footing. Next here it is written as F6. F6 is the name of this particular footing. Then we have F4 here. F4 is the name of this particular footing. Then we have another F4 here. F4 is the name of this footing. Then we have F5 here. This is the name of a footing. Then we have another F3 here. This is the name of a footing. Then we have another F3 here. This is the name of a footing, F3. This is CF2. We'll come back to the CF2 later. Then again F4 and F2. So wherever there is one column, everywhere there was one column, that is why we have given one footing. Here what has happened, yeah, we'll come back to that later. And then we had a circular column here, right? We had two circular columns, and one on this side and one on the other side, right? So this is how the plan was. Two circular column, two circular here, one circular here, and one circular column here. That is why the structure consultant has given a combined footing. Since, see, if there is footing, I'll take an example of this. Let us say this is a footing, and over that if I have one column, then it becomes my isolated footing because there's only one column. Now let us say on this particular column, if I'm keeping two, let us say this is my column, let us say this is my column, this is my footing, one column is here and the second column is here. If a footing is carrying more than two columns, then we call it as combined footing. We call this as combined footing. That is why what has happened here, since there is two column and there is only one footing here, we call this as CF1. C stands for combined, F stands for footing. Since this is the first footing under the combined footing category, we call this as CF1. And this is also the this is also a combined footing. Since the size remains the same, the structure consultant has given the name has CF1 and CF1 for both the footing. Whereas if you observe it here, if you observe it here, so this is CF2. Maybe the size of this footing is different from the size of the footing what we saw for the combined footing. That is why the structure consultant has given this as CF2. Again, CF2 stands for combined footing 2. Whereas F1, F2, F4, F5 are the different size of the footing. These things we are going to get when we do the analysis with the help of ETABS software. The ETABS software is going to give us the load coming on the footing. We'll try to see that once we understand all these things. We'll try to see how the ETABS is going to give us a result and how the structure consultant does all these works, right? So based on that, they are going to do the grouping of a footing, and this is how the drawing is released, right? Now we'll try to understand this. Yeah. Yeah. So this is the distance between grid line to grid line. The distance between A and B grid line is 8 feet. The distance between B and C grid line is 6 feet 6 inches. The distance between C and D grid line is 7 feet 1.5 inch. The distance between D and E grid line is 1 feet 9 inch. The distance between E and F grid line is 6 feet 10.5 inch. And the distance between F to the outer, I mean the boundary of a house is 4 feet 4.5 inch. The same logic holds good even on this side. The distance between 1 and 2 grid line is 18 feet. The distance between 2 and 3 grid line is 7 feet 1.5 inch. And then the distance between 3 and 4 grid is 5 feet 9 inch. The distance between 4 and 5 grid line is 3 feet 1.5 inch. And that's it. That's how it goes, right? So that is how it is. 5 to 6 it is 14 feet 1.5 inch. So these things again we get from architectural drawing itself. From the architectural drawing, wherever we have a from the architectural drawing, wherever we have the columns, so these are my columns. In between these two columns, whatever is my distance, that will be the grid line when I release the drawings as a structure consultant, right? So whatever distance you are seeing in between these two, yeah, whatever distance you are seeing, it's the same thing taken from the architectural drawing. So what is the total size written here? It is written 30 feet, 37 feet and 6 inches. The same thing will come here. That is why we can see here 37 feet 6 inch. So whatever drawing you get here, it's taken from the architecture drawing itself. There might be slight variation. There might be slight variation of 1 feet or 1.5 feet, but usually you're going to get the same thing. Similarly, concentrate here. Again, it is 2 feet 6 inches from the face of this wall to the boundary of this house. That is why you can see here it is 2 feet 10.5 inch here. So that is fine. He has taken outer distance here. So this is the a dimension what I'm getting. So this is how we need to understand it. Now we'll try to get into this. Yeah, we'll try to see this now. So what is written here? It is written the name of the footing is F4, and what is the size of the footing? The size of the footing, you have to refer it here. You can see it, right? From the outer face to the outer face, what is mentioned here? 7 feet 0 inches. Similarly, what is mentioned here? 6 feet 6 inches. So this distance what we have, it is 6 feet 6 inch, and this distance what I have, it is 7 feet 0 inch. Since initially it was written all the dimensions are in inches, if you can remember. Yeah, we'll see that it was mentioned here all the dimensions are inches. That is why you can see all the dimensions are inches here. Just in case if it was written in meter, then we would have got the reading, we would have got the dimensions here in the meter, right? So yeah, so now what is the distance given here? It is a 6 feet, but from this center line. So what is this? Where is the center line? If I'll take this. So if I make this grid line run in this way, and if I make this grid line run in this way, Yeah, so this is my center point what I get. From this center point you have to mark 2 feet 10.5 inch on this side and 3 feet 7.5 inch on this side. This is what do you understand by this? I'll try to erase it now. In the same way, this is my center point what you can see here, and from here, yeah, yeah, from here to here it is 3 feet 1.5 inch. From this to this outer face it is 3 feet 1.5 inch, and from this center to to this outer face it is 3 feet 10.5 inch. So if we add 3 feet 10.5 inch and 3 feet 1.5 inch, the total comes out to be 7 feet, right? So this is how it is to be read, and this will be the same execution will be done on the side. If you are finding it difficult to understand how the execution is done, as I mentioned in the beginning of my course, you can watch one of my course on building construction step by step, where I explained you everything in an animated way, and the practical videos have also been showed there. So here I'm just teaching you how to read all these drawings. It's a You have to understand all these things. If you're finding it difficult, you can refer there, right? Similarly, come to this footing now. So it is written here 8 feet 6 inches, the size of the footing. The name of the footing is F6, and the size of the footing is 8 feet 6 inch, and on this side it is 8 feet. So from the center line, this is my center point now. This is center, right? It's meeting here, so this becomes my center. From this here to here it is 4 feet, and from here to here it is 4 feet. So 4 comes out to be 8 feet. Similarly, it is 8 feet 6 inch here. So from this center it is 4 feet 7.5 inch. From this center it is 3 feet 10.5 inch. Similarly, this is F4 footing what I have. So its dimension is 6 feet 6 inches. So from here it is 3 feet 3 inch. From this center line to the outer face of the footing it is 3 feet 3 inch. Similarly, it is 7 feet on this side. So you have 3 feet 10.5 inch here, and you have 3 feet 1.5 inch on this side, right? So the same logic holds good everywhere. Similarly, if you go here, yeah, we'll try to discard it. Yeah. Similarly, if I come to F4 footing, again the F4 footing it is 6 feet 6 inch, and this side it is 7 feet. So this comes out to be 3 feet 3 inches from the center to the left side, and 3 feet 3 inch from the center to the right side. Similarly, it is 7 feet here. So it is 3 feet 4.5 inch on the left side from this center line to here, and from this center line to the other side, it is 3 feet 7.5 inch, right? So all these things we are going to get. How we are going to do all these things we are going to get with the help of a ETABS software. From the ETABS software we'll be getting the load, and based on that we'll be working out on all these things. We'll try to see this how these things we are going to do, like why we are going to name it as F4 footing, why we are going to name it as F2 footing, right? Why it is F1, why it is F1 footing here, why there are two number of F2 footing, and why there are two number of F1 footing, why not all the footing name has been given similar, right? It all depends from the size of the footing, what is the reinforcement coming there. Based on that we are going to do the grouping of a footing, right? We'll try to see all those things when we take up ETABS. We'll try to understand with the help of ETABS. Next, coming to the combined footing. So again, it is a combined footing. I have two column here. So the this distance is 3 feet 6 inches. Yeah, so this distance is 3 feet 6 inches, and this distance is 5 feet 3 inches. Similarly, here also it is 5 feet 3 inches, and this distance is 3 feet 6 inches. So this is how you have to understand the footing drawing. This is called as footing layout drawing. So these are the grid lines, and this is how we have to understand the same thing whatever I've explained you. So each footing has its name, and the size of the footing is given here. Only the thing is the depth of the footing is not mentioned here, right? We are getting what is the length of the footing. The length of the footing is 7 feet here, and the width of the footing is 6 feet 6 inches. Whereas the depth of the footing is not mentioned here. For that, we are going to get one more drawing that is called a schedule of footing. In the schedule of a footing, we are going to get the depth of the footing and also the reinforcement, right? What diameter of the bar has to be used. Let us say I'm considering F4 footing. So I know the size of the footing is 6 feet 6 inch and it is 7 feet. But whereas the depth of the footing is not mentioned here, whereas what are the diameters of the bar that you have to use in this footing, the horizontal bar, the vertical bar, and what is the spacing of the distribution bar that we need to keep, even that is not mentioned here. So those things we are going to see from a schedule of a footing drawing, where everything will be put up in a form of a table, and from there we'll try to understand them. Yeah, so I hope it's understood up to here, and we'll see you back in the next lecture. Thank you.